In a modern living room, the technology is invisible. You press one button and the interface instantly serves up high-definition video. But this level of simplicity didn't exist 20 years ago. In the early 2000s, enthusiasts were chasing a concept called convergence. They wanted to take the raw, limitless power of a desktop PC and force it into the simple, lean-back environment of a television set. To understand the friction of this era, we can look at the work of Mikael Lindquist, a veteran Swedish tech journalist. His columns from the time document a constant uphill battle to build a stable media center for his projector setup. Before builders moved to custom PCs, the gold standard for the living room was actually a modified original Microsoft Xbox. By hacking the console, users could run Xbox Media Center, or XBMC, which offered a remote-controlled interface that was years ahead of anything on a desktop. But as capable as the Xbox was, it remained a compromised tool. Achieving true convergence meant moving beyond game consoles to bring the full processing power and storage of a custom computer directly into the media cabinet. The shift toward custom PCs was driven by two demands: the arrival of high-definition video files and the desire to record live digital television directly to a hard drive. The Xbox's hardware was based on a custom Pentium 3 architecture. While it was great for standard-definition games, the processor and limited memory hit a hard ceiling when it came to decoding high bitrate HD video. To handle the math required for HD playback and DVR recording, enthusiasts had to build specialized computers from the ground up, using desktop-class components. But the moment these builders brought office-grade hardware into the living room, they encountered three engineering bottlenecks that made the resulting systems almost impossible to live with. The first bottleneck was purely physical. A standard early 2000s PC relied on high RPM fans to keep components from melting. In a quiet living room, the constant whirring ruined the audio of any movie you were trying to watch. Builders tried underclocking, slowing the CPU to reduce heat, which ruined video playback. Next, they installed passive heat sinks and heavy foam mats to block noise, but this created a thermodynamic trap. The insulation trapped heat until the system crashed entirely. Physics forced a compromise that no one wanted. You could have a quiet PC or a powerful PC, but at the time you couldn't have both in a media cabinet. Even a perfectly cooled machine was only as good as the code running it, and the software ecosystem of the era was deeply fragmented. Users were torn between open-source projects like MediaPortal and commercial software like Medio. Neither platform had standardized drivers, meaning that the specialized TV tuner cards used for recording would often stop working after a single software update. The only truly stable architectural choice was MythTV, a Linux-based system that could route video from a central server to multiple screens throughout a house. But the technical barrier was massive. Using MythTV required diving into a command line interface to manually compile drivers just to get a TV signal. Without unified standards, a regular person needed the skills of a system administrator just to perform the simple act of watching a television show. The final, most frustrating hurdle was the Electronic Program Guide, or EPG. A DVR is useless if it doesn't know when a program starts or ends. Outside of the US, there was no centralized provider for the schedule data. Enthusiasts were forced to use an unstable, community-built protocol known as XML-TV. Users ran automated scripts to scrape schedule data from website HTML and drop it into their TV guide grid. But this was incredibly fragile. If the website layout changed slightly, the script broke instantly, and all scheduled recordings failed. This forced a cycle of maintenance. They had to rewrite code, fix missing episode titles, and manually update show logos just to make the interface acceptable. The EPG crisis turned the DIY media PC into a grueling technical chore. Without a standardized pipeline of schedule data, the system required the constant, manual intervention of a developer just to function. Microsoft tried to capitalize on this enthusiast demand by launching Windows XP Media Center Edition, which integrated a TV-friendly interface directly into the operating system. But Microsoft's solution came with heavy strings attached. They enforced strict digital rights management and required specific, proprietary hardware that limited the very freedom enthusiasts were looking for. Mikael Lindquist eventually realized that the time spent configuring these DIY systems was simply too high. He noted that in the future, it would be much more practical to buy a pre-built system and avoid the nights of technical labor. This shift marked the end of the general-purpose PC in the living room. It was replaced by specialized appliances that traded total customization for the stability of a closed ecosystem. The DIY spirit survived, but it changed form. XBMC evolved into Plex and Kodi, which now run as simple apps on low-power hardware that doesn't need a cooling fan to decode 4K video. The legacy of this era is a lesson in standardization. The HTPC proved that raw computing power is secondary to a reliable software ecosystem and open data APIs. Today's immediate access to high-definition video is built upon the solutions developed during this era of friction. We swapped total local control for a system that actually works. But those first reliable clicks were earned by enthusiasts who spent their nights debugging scrapers and silencing jet engine fans.